Hey everyone, welcome back. Till now we have covered STL containers, time complexities and space complexities. So far we have only covered theory part. From now on we are going to solve problems based on STL containers, and after solving and practicing the problems based on containers we will move ahead on to DSA. So today we are going to solve problems using vector containers. So you will be able to know how to use a vector to solve a problem. Okay, let's move to the first problem. First problem is sum of elements. You have a array of size 5. Okay, so you have to write a code to sum all the values. Means you have to sum 1 plus 5 plus 7 plus 9 plus 4, and you have to print a sum of this number. So now what we need to solve this problem, right? If we are doing a sum, we have to store somewhere, so we have to declare a sum variable, and we are taking array to store the data, so we have to declare the array also. Okay, so now here you can see we are summing them up one by one. That means we are iterating on the array itself. So for iteration we can use loops, right? Because we are doing a repeated task. At every iteration we are adding them up in a variable of sum, right? So initially we have I equals to 0. That means we are here and our sum is 1, right? Because at 0 index we have sum 1. Now at I equals to 1 our sum becomes 1 plus 5, right? Because we have to keep the previous value also in the sum. At I equals to 2 our sum will become 1 plus 5 plus 7. At I equals to 3 our sum will become 1 plus 5 plus 7 plus 9. At I equals to 4 our sum will become 1 plus 5 plus 9 plus 4, right? At I equals to 5 our loop will stop. Let's write a code. First you can declare and initialize your array, or you can use vector also. So to declare vector we will write like this. Okay, now in this case you already initialized your values. Now there is another way where you will take size from the user itself. Means here you have a size 5 which you have already decided, but what happens, instead of 5 elements here there are going to be 10 elements. In this case you don't know, right? There are going to be 10 elements, so you are going to declare a size and taking a input. After that you can write size here. So in runtime your array size will be decided based on the size input. Okay, similarly you can do with the vector also. Now you declared a size of vector or array, you also declared a vector. Now we have to take input. To take input we have to use loops, because at every iteration we are inserting only one value at a time. So you have to use loop, because you cannot insert all the values in a vector. So we will write for int I equals to 0, I less than n, right? Because our size of array is 5 and we will go till the 5 minus 1, which is 4. So here I less than n means it will go till the 4, then I plus plus. Then to take input we will write scene, then v of I. So the index number will change here and the value will keep inserting at that index. Okay, now this code is only for taking input. Now we have to write a code to sum the values as well as to print the sum. So first we declare our sum initialized from 0. Then again we will write same loop 0 to n. Okay, then we will add sum equals to sum plus v of I, and here we can print our sum. Now initially our sum was 0. Now we are at index 0. So at index 0 our value is 1, value of sum is 0. So 0 plus 1 will become 1. So the 1 will assign in the sum variable itself. Okay, now the loop continues, and at the index of 1 the value becomes here 5, right? Because it is a v of I, so value becomes 5, and the value of sum is 1, because in previous iteration we added the 1 to the sum. So 1 plus 5 will become 6. Now the sum value becomes 6. Okay, in the next iteration the value of v of I is 7, right? And the value of sum is 6, because the 6 value we got in the previous iteration. So 6 plus 7 13, right? Now the sum value become 13. So that's how we are iterating and storing our sum value in the same variable, means we are summing them up here and then reassigning here, then we are using value here again, then reassigning again, and here we are printing our sum. And let's run this code. Okay, let's create a new file, practice.cpp. Okay, this is our basic structure. Now first we have to declare the size of a vector, so we will write int size, then we will take input of size, then we will declare a vector, then we will write vector of int, then we have size. Okay, so remember one thing, you cannot declare your vector before the size variable, right? If you declare your vector before declaring the size itself, it will give an error. Now let's take input for int I equal to 0, I less than size I plus plus. Okay, then scene v of I, then we will declare our some variable, then okay, let me copy paste it because it is going to be same loop. Now let's change it, sum equals to sum plus v of I. Okay, now b added the values to the sum. Now let's print it. Okay, let's take a size of 5. Okay, now let's take a value can be taken as a space separated or a enter separated, means you enter 1, then you can space, then 5, then space 7, space 9, space, then 4, then enter. You can see it is printing 26. So this is the sum of these values. Okay, first we declared the size of the vector. Okay, then we declared vector itself, then we used for loop to take a input, then we declared a sum variable which is going to store sum of the values, then we used one more loop which is adding all the values to the sum, then we are printing here. So whenever you are writing a program, you have to follow every single step, you cannot skip any step. Okay, now let's move to the next problem, reverse the vector. Okay, so we have a vector of size 4. Now you have to reverse it means you have to write in this order. Okay, so the values from back will come to the front. Okay, now to reverse a vector we have two methods. One is reverse function which is available in the C++, and another is custom reverse, means we can create our own custom reverse function. Okay, so let's create our own custom reverse function. So this is our vector, our index is 0 1 2 3. So whenever we initialize a I, we always starts from 0 in the for loop, right? So we are at here, then we will move till the index 3. So at I0 it will print 10, at I equals to 1 it will print 20, and at I equals to 2 it will print 30, then I equals to 3 it will print 40. What will happen if we start our loop from 3 itself and move from back to front? So we can say at I equals to 3 it will print 40, at I equals to 2 it will print 30, at I equals to 1 it will print 20, at I equals to 0 it will print 20. So here you can see the order got reversed, right? So we just have to loop from the back to the front to print in a reverse. Okay, let's write our code. So for int, now we are not initializing from the 0 but we are initializing from the back. So what is the end index of the back? For this 3, but we know the last index of an array or vector is n minus 1, right? Now we have to go till 0. We have to keep running the loop until our I is greater than equals to 0, means if I is at 1 or 2 or 3, the loop will keep running. Even if I adds 0, the loop will still keep running. As the I becomes minus 1, the loop will stop. Now initially we had a 3, then 2, then 1, then 0. So we are decreasing our index. So we will write I minus minus. Okay, now we can print this vector itself. Now this is only printing, not actually reversing our vector itself, means you are here printing these values but the vector will remain same. Okay, so this is only printing and our vector will remain same. So now we have to reverse the vector itself. So what you can do, you can create another vector which is going to store your reversed values, right? So let's create another vector which is going to vector of int of, let's name it reverse. Okay, here instead of this I can do right reverse dot push back of vi. Okay, push back function add one value from the back. So now in reverse function we have a value like 40, 30, 20, then 10. Now you can print this vector itself, or you can run a loop again and update the values of your original vector using this reverse vector. Okay, let's first print our reverse, then we will look into this. Okay, this is our previous code, so this one will remain same. We will remove this one and also this one and this one. Okay, now we are printing in a reverse, so our I will initialize from size -1 because we are starting from the last index, and it will go till I greater than equal to 0 and I minus minus. Now we will print. Okay, I'm going to copy this input. Let's print it. Okay, here you can see it is giving me the reverse order 49751. Now here we are only printing it. Now here you can see these two lines are our input. Okay, now this one line is our reverse print, means we are printing the value in reversed order, and this is our original vector, so there is no change in our original vector. You can create new vector reverse, then instead of printing it here you can add the value itself. Okay, then you can print it here. Okay, so this time we are printing reversed vector, so let's run it. Now here you can see it is printing me the reversed order which is in the reversed vector. Now I want to make a changes in this original vector itself, so we have to use loop again and assign the values. Means let me copy paste here. So now what is happening here, at 0 index the value of 0 will be assigned to this vi itself. So let's print vector. Here you can see it is printing me the reversed vector. So initially we had a value of 15794. Okay, this is our vector we created a reverse vector which is having value 49751, right? And the index for these are 0 1 2 3 4. So what is happening, at v index 0 equals to we are accessing index of 0, so the value at 0 will updated by 4. At index 1 the value will updated with the value of 9. At index 2 we will update the value of 7. Similarly here. Okay, so here we are assigning, right? So at 0 index we are assigning the value of reverse at the 0 index. So in this way we are able to reverse our original vector also. Now let's analyze the time and space complexity. What is the time and space for this program? So let's see, for this solving the problem we run a loop from the reverse with the size of n or size itself. So we can say our loop is iterating for the n times, right? So for this loop we can say it is big of n. Now there was another loop which is assigning the values, so it was also running for a n times, so we can say it is taking big of n also. Now there was another loop which was printing, so it was also taking big of n, right? So our total time complexity will become n plus n plus n. It is 3n, and one of the rule is we can ignore the constant, so our time complexity will become big of n. Now what is the space complexity? Now there is two vector we declared. First one was v and the another was reverse, right? So v vector is for taking an input, so we will not consider it in a space complexity. This is our input space, this is our input space, and the reverse is our auxiliary, because this reverse vector is used for storing the reversed values. So our space complexity will become big of n because we are using reverse to solve our problem, and also this is our extra space, so our space complexity is big of n. So our time is big of n and space also big of n. So our time complexity is big of n and space complexity is big of n. So can I make this big of 1? Yes, I can, but we have to make changes in our code. So means we don't want to use this reverse vector. Let's take array again. 4, okay, 1 5 7 9 4. Okay, so can we swap this value? Then it will become 4 1 9 5 and 7. This is our reverse, right? So and this is somewhere our middle line. So we have to reverse value from the back, value from the front to reverse our array. Let's take example with another vector 187954. Okay, this is our vector. If I swap these two values, and swap these two values, will this vector will reverse? Let's see. 4 1 5 8 9 7. Here you can see 1 1 1 8 8 7 7 9 9 5 5 4 4. So our vector got reversed. So in somewhere between there is a line which is separating two portion, left portion and right portion. We just have to reverse the values left with the right. So our loop will run till the middle itself. So we can say our loop will run n by 2. Okay, size of 6 by 2, it is 3. So 0 1 2 3 and it is less than, so our loop will run 0 1 2. So this value will be covered left side. Okay, now we just have to swap the values from the right side. Okay, so let's clear it first. So we are at index I equals to 0 and this is index somewhere n minus 1. Now we have to swap between them, right? So there is a function in C++ which is a swap, where you can put your values vector of 0 or vector of n minus 1. So it will swap these values inside the vector. Okay, now we know our first index which is going to be I, but what will be the index here, right? Because we are at I equals to 0 and we must be available at this index also to swap these values. So we have one index which is I, which is equals to 0. Now we need this index. So this is n minus 1 is last index. Okay, so this is our from the front, this is from the back. Here we have 0. Let's take a size n equals to 6. So we have n minus 1. So we have here 5. Okay, now at 0 we need a 5. At 1 we need a 4, right? Because here is 1, here is 1 less. So it is 4. At 2 we need 3. At, right, because we will go till the 2 itself. 0 0 1 2 itself. Okay, so how we can formulate this pattern, right? Means at I0 we need 5. So for this 5 we can say it is n minus 1 itself. For 1, here we are increasing 1, here 1 is decreasing, right? Here from 0 it is increasing 2, here decreasing minus 2. So we can say here in I we are increasing with some number, similarly we are decreasing with the same number. So we say n minus 1. So for 1 we are decreasing with the 1, right? For 2 we are decreasing with the 2. Here you can see this pattern is similar to the I1, or here you can also write 0. Here you can see it is same pattern, 0 1 2 0 1 2. So can we write n minus 1 minus I, right? So at I equals to 0, our last index will be 5 minus 1 minus 0. It will be 4. At I equals to 1, 5 minus 1 minus 1. It is 3, right? So here we can write n minus 1 minus I. So what will happen? Simultaneously our back and front will be at a certain index. Okay, let's code this up. Okay, let's remove our reverse, then also this one. Here we are taking input. Okay, now we have to write one more loop to swap them up. So we will write here, then we will go till I less than size by 2. Then we will write swap function which is swapping from the front as well as from the back. Okay, this is not it should be size. Okay, now let's run it. Here you can see it is reversing. Now what is the time complexity and space complexity? So here it is taking big of n by 2. So 1 by 2 is constant, so our time complexity will become n, right? Here also our time complexity is big of n, right? So our overall time complexity will become big of 2n and space complexity will become big of 1. Okay, also this swap function only takes big of 1 time complexity, so overall time complexity is big of 2n and for space big of 1. This is our custom reverse function with the improved time complexity, and to simplify it we just have to write reverse function which is built in C++, reverse, then b dot begin. This is our begin iterator and this is our and let's run it. Here you can see it is reversing. Okay, so for reversing an array you can use this function, but sometime you should know how to reverse the vector or array without using any inbuilt functions. Okay, in the next video we are going to solve more problems. Try to solve these problems by yourself so you will be able to understand what is happening. Also try to take different inputs to run this code. Thank you everyone, have a nice day.